So this is the sixth session of Python programming, and today we shall be learning about writing our own function in Python or defining our own function in Python. Fine. So as such, you all must be knowing what we mean by function. This is the code which we have done in the last session, and this is about finding the factorial and displaying the Fibonacci up to the given number. And here we have simply did it using a plain code. I mean to say without any function. So we can do the same thing with the help of function. So what is the use of a function? Let's first discuss on that, and then we'll talk about how to define a function in Python and what are the major differences of defining or creating your function in Python as compared to creating or writing the functions in other programming languages like C, C++, or Java. So to start with, you need to know what is the use of a function and why do we go for a function. So can you please put some light on this? Anybody can just unmute your mic and tell me what is a function and what is the use of a function. Why do we have a function in programming? Now this is same everywhere. This is common. So if of any programming language, you should know the meaning of function. You should know why do we have a function, because it is same for all the programming languages. Yes, any student. You can please unmute your mic and let me know. What is function? Why do we have a function? Okay, to start with. The key says function is set code which we can call anytime we want instead of repeating that line of code. Function is block of code used to perform a specific task. Okay, good. And what else? Okay, that's fine. That a function is a block of code or it is a set of statements which are repeatedly executed or which we want to do repeated number of times. So instead of writing them multiple times, we'll be putting them all together in a single code, a single block of code, and we will call that block of code whenever required. Okay, and that block of code will become a function. So what do we achieve out of a function when we use a function? This is fine. That when you have any repeated task, so you do that task into a block of code and you name that block of code, so that becomes a function. And then whenever you need that code, you can just call that function. What is another thing which we achieve out of these functions? The first thing, a repeated task can be done once, and whenever required, we call it. So that is the first achievement. Second is better readability. Aditi Patil is saying reusability. Daniel is saying modularity. Good, very good. So these are the most important things which we get out of a function. The first one is the reusability and second one is the modularity. So reusability is nothing but what we were discussing, that you will be writing a code once, so you will be making a block of code, and then whenever and wherever you need it, you just call that code, you just call that function. So that becomes reusability. So we are defining it once, and then we are reusing it number of times in our own program, in another program, or wherever we can, or wherever we want to. So that is the reusability. The second most important aspect of function is modularity, and this is very important. Now, we know modularity is nothing but you divide a major problem into sub-problems, and that way you handle the problem. Okay, so this is something like divide and conquer strategy, where what do? We divide the major problem into smaller sub-problems or into smaller modules or something like that. And then for each subproblem, then you can write one function. Okay, so what you are doing, instead of writing a single piece of code to solve the entire problem, you are dividing the problems into subproblems, and then for every subproblem, we are writing a code. So for every subproblem, you can write one function. Okay, improves the overall modularity of the code or the program. Okay, so two important things that we gain out of a function, irrespective of a programming language, are what? Reusability and modularity. Very good. Now, every programming language has its own style or its own syntax of defining the function. Okay. In a few of the programming languages, they are common. For example, when you talk about say C, C++, and Java, with some minor differences, with some minor changes, more or less they are common. So the syntax about how to define a function, how to use a function. So these are common in this programming language. In Python, it takes a little different approach. Okay, conceptually it is same, but when you talk about syntactically, when you talk about grammatically, then it is little different. What do we do in Python? Let me create a new code for it. Funsam.py. To define a function, we have a keyword called def in Python. So def is a keyword to define a function. Okay. So the first of a function definition, word, then the space, and then the function name, and then the argument list over here, separated by comma, obviously. Then since after the function name, you have a block of code. And in Python, whenever you have a block of code, it is indented. Okay, so we make use of indentation. That's why we'll be going for colon over here. Okay, and then starts the body of a function. So I can have statement 1, I can have statement 2, and so on up to statement n. So we can have this many number of statements. Sorry. Simply write this way. And then I can go for returning the values whichever I want to. So this is the syntax of defining a function in Python. A very straightforward and a very simple syntax. What we are doing, we are using a keyword def. That's all. No need to specify the return type because type is not important in Python. I mean to say it is dynamically typed language. So since it is dynamically typed language, you did not have to specify what type of data you will be returning or whether you will be returning any data or not. Not at all required. In C, C++, and Java, we need to write the return type that will specify the type of a data which you are returning. But in function, we did not have to. So that simplifies the function definition in Python. Function name, obviously it must be there. It's an identity of a function. Then the argument list, separate, comma separated. So I can have argument 1, comma argument 2, comma argument 3, and so on. Now, interestingly, in Python, when you define the argument for a function, here also you need not have to specify the type, since it is dynamically typed programming language. So this further simplifies your task of defining a function. Okay, because you need not have to worry for the type of argument. It simply means that I do not define any type of argument. So I can pass, say, if there is one argument for my function, I can have a number of arguments. So if there is one argument for my function, so I can pass integer data to this function. I can also pass a float data to the same function. I can pass a string data to the same function, or I can even pass a complex data or any data of my choice. Since the type is not defined here, and the type need not have to be defined here because it is dynamically typed programming language. So that is a further level of simplicity about defining the function in Python. Otherwise, in most other programming languages, you need to define. You need to write, yeah, what will be the type of the argument. Okay. So here you need not have to define that type. And then comes your body of the function, statement 1, statement 2, and so on to statement n. And then the last is your return. Now, if you do not want to return anything, there is no need to write the return statement. If you want to return any value, then you can write return val, something like that. So you'll be returning that value. Interestingly, in Python, you can return multiple values. So I can write return val, val1, val2, or I can return a collection itself. I can return a list, I can return a tuple, I can return a dictionary. So it's up to our requirement. Okay, so that's the simplicity, and that's a best thing about defining functions in Python. You did not have to write the return type. You did not have to specify the types of the argument, and then your function can return multiple values. Your function can accept n number of arguments, and your function can return multiple values. Okay. Only one thing you need to remember, that you need to make use of a def keyword. So this is about the syntax of defining a function in Python. Now suppose if I want to define a function for factorial, what I will be doing, def keyword, then the name of my function, let me call it fact, and then I will be passing a number of which I need a factorial. So let me call it num. I need not have to specify the type. Okay. Then starts the body of my function. So here I will be coding. I need to find out the factorial. I will be saying, say, f equals to 1. Then whichever loop I want to make use of. Suppose I want to go with a for loop. So for I in my range, which should start from 1 and which should go up to num. So it should be num plus 1. And then I would be simply saying f equals to f into I. That's all done. And then left indentation, because now I simply need to return a value, and that value is f. Done. So this becomes a function for finding the factorial of a given number. Okay, and the name of a function is fact. So this is how you will be defining a function in Python. And the way we are defining the fact function, the same way we can define any other function. For example, if I want to make, there are a few more things which are supported in Python, where the way it is supported in other programming languages. For example, what I mean to say, you can have a default argument. So I can make it num equals to 1. So 1 is the default argument. So if I do not pass any value to a factorial function, by default the value would become 1. Okay. So this is how you can have a default argument in Python function. Then you can have a keyword argument also. Then you can pass n number of arguments also. For example, this is the way by which I can pass n number of arguments, just by making this argument as star and then the argument name. So star num. So the moment I write star num, it becomes something like a list. So what it will have n number of arguments. So if I want, I can pass one argument. If I want, I can pass two arguments, or I can pass n number of arguments. It's up to me. Fine. Now this is no more a single number. So for example, if the first argument is my number whose factorial I want, so I need to simply write here num of 0. So num of 0 plus 1. Okay, because this num is going to have n number of arguments. So my first argument I am assuming to be a number whose factorial I need to find. The second argument could be any message. The third argument could be something else, and so on. So it all depends upon your requirement, what you need to do, what you want to do in your function. So depending upon our requirement, we can play with it. Next important thing about Python function is that in the Python function, immediately after this colon. So immediately at the start of block, I repeat, immediately at the start of block, here you can have a constant multi-line string. I repeat, you can have a constant multi-line string like this, a constant multi-line string. Okay. Now this constant multi-line string is called a doc string. It's called as a doc string. What this string would do, it will give you a documentation of your function. I repeat, it will give you the documentation of your function. For example, I can write here what this function is doing. So basically, this function would return a factorial of a given number. So this is my doc string, and it says that this is a function which returns the factorial of a given number. Now, what happens when you have a doc string like this defined for your function, and whenever you want to use your function, for example, I want to use my function over here. I will be calling the fact function, and suppose I will be passing phi to this. So the moment, see here carefully, the moment I move my cursor to this fact, it gives me the doc string. So what is the doc string? Return a factorial of given number. Okay. Now, this is just to say you that it's a doc string. Basically, what do we have? Only a message. So return a factorial of given number. Now the same I can do by writing like this. Fact, the name of a function, dot operator. So your fact is something like an object, you can say. And if you see the first option is underscore underscore doc underscore underscore. Please see here carefully. Underscore underscore doc underscore underscore. Okay. So I can do this. What it is called? This is called double underscore. Double underscore. Now this double underscore in a short form this double underscore is called as Dunder. Okay, so we simply pronounce it as Dunder doc. So whenever you have a double underscore before the name and after the name, so we simply call it Dunder, and then whatever the word we have. For example, here it is doc. So we will read it as Dunder doc. Okay, and likewise, you have Dunder call, you have Dunder annotation, you have Dunder class, Dunder closure, Dunder code, Dunder defaults, and so many things. Okay, Dunder dir, Dunder dictionary, Dunder doc, Dunder equal, Dunder format, and so on. And all these are by default provided by your Python. So I would be going for Dunder doc because I want to display the doc string of my function fact. I want to display what? The doc string of my function fact. Now, since here I can have some issues, so let me make this comment. And now into our code, we have this. Okay, let me execute this. So the factorial of phi is 120. So 120 is displayed. And on the next line, you have return a factorial of given number, which is the doc string of my function fact. Okay. So this is a very good practice. Whenever you define any function for anything, you should have a doc string. So in Python now, whenever you will be defining the function, the doc string should be there. So what happens whenever you use this function anywhere inside your program or inside someone else's program, if someone else is also using. So the moment that person hover the mouse over the name of your function, that person would get a help. would get a docstring like this. Now this is because of VS Code. If programmatically you want to see what is the definition or what is the task of this function, how this function is working, okay, so that can be done with the help of this Dunder doc. Okay, I just only need to know the name of that function which I will be using, which I will be knowing while using it. So I can simply print the function name dot Dunder doc. Now that will display or that will print the docstring of that function. Yes, of course, if it is defined. If the docstring is not defined, then you cannot do anything. Now, if I hover my mouse over here, so I just get the name of a function. And likewise, if I display, so I just get what? The factorial of phi, and I get a value none. Now, none is also one type of value in Python. So I get a value none because there is nothing available into the docstring. So the output is none. Okay. And if I make this the moment I execute it, so I get the docstring, return a factorial of given number. Okay, so this is a very good practice. I strongly recommend each one of you that you should have a docstring for every defined function. So whichever function you define, you should have a docstring for that. Now come back to our code. So this is for the session6.py. Now what I have done into this, I have already defined a fact function for you. So define fact, docstring is defined, return the factorial of given number, and then the same code. And then now onwards, we will have one more practice. So instead of putting it into your Python file straightforward, we'll be putting everything into a function named main. Now the function we have fact function, then we can have Fibonacci function and so on. Now in the same way, we can have a main function. Now what we are doing into the main function, we are putting the main task of our script, of our Python code. Okay, so we are defining a main function. Now into this, I'm making use of a infinite loop. So while true, I'm asking for a number from the user. So user would give us a number. I am converting it into integer because input will return a string. Then factorial, printing the factorial of n is fact n. So here I am calling the function fact. So this function we are calling over here. Okay. So fact function would be called over here. And then I'm taking another input from the user. Do you want to continue? Yes or no? And that I'm taking into ch, and I'm not converting it, so it will be of type str. Then I'm checking if ch equals to capital N into single quotes, since it is a string, or ch equals to small n into a single quotes, again because it's a string break. So if I do not want to continue, so I would be breaking this while loop, else this while loop would keep executing. Else this while loop will keep executing. Okay, do you understand this? Yes. Is there any doubt? Is there any issue so far? Okay, good. Now, what we are doing now, since fact is one function, main is one function, and I want to execute my code from the main function, I should call the main function. What I mean to say that suppose I do not have this, and I execute my session6.py. So I would say Python session6.py. I do not get anything because what's happening, though I do have two functions defined in my Python script or Python program, I am not calling any function. Now, since the functions are not called, no execution would be done. That's what's happening. What I need to do, conceptually, I want to call the main function first. So from the main function, it will go into an infinite loop, and inside the infinite loop, it will ask for the number from the user. It will call the factorial function for that number, and it will display the factorial of that number. Then it will ask for the user, do you want to continue? If the user says yes, then this infinite loop would continue. If the user says no, then only we are breaking this infinite loop. So we need to call the main function. Unless and until we call the main function, this will not be happening. Okay. So what I am doing here itself, I can simply call the main function like this. Let's see what happens. So yes, the function got executed, the function got called, and the function got executed, and then it is asking us for the number. So enter the number, I say it's 5, it says factorial of 5 is 120, then it asks me, do you want to continue? I say yes, I want to continue. Why? It asks me again, enter the number, and now I say 6, and it says factorial of 6 is 720. Do you want to continue? I again say yes, I want to continue, and then enter the number, I say 10, and it says me factorial of 10 is this one, and it asks me again, do you want to continue? This time I say okay, I don't want to continue now. So I say n, and it comes out. Okay, so this is how the code got executed. Now, if you see here, so it is a very simple approach wherein we have divided our program into two functions. The first function is the factorial function, the second function is the main function. Okay, and then we are simply calling the main function. Fine. Now, what happens that when you work on packages, when you work on modules, and you want to make use of functionality of one module of one program into another program, or in short, what I mean to say that I want to make use of the fact function of this program in some other program. In short, in a very simple language, what I want to make use of, I know that in session6.py, I have already defined a fact function which works very well without any issue, without any problem. So now whenever I need to find the factorial of a number, so instead of writing the code again, I will be using this fact function of session6.py. Okay. So reusability of the code comes into the picture. In this program, we have divided this task into two important tasks, the factorial and the main task. So this is called modularity. Fine. Now, when I want to make use of this fact function or any other function, if you got 10 functions defined in this program and you want to make use of those functions somewhere else in someone else's program, so what we will be doing, we will be importing it. What we will be doing, we will be importing it. And whenever you have something like an import, so you will be importing from a program, from a module, from a package. In that case, what we need to do, we need to call this main function inside every Python code. Wherever you have divided your code into blocks, like you have divided your code into functions, and then you have a main function, and you want to call the main function. So we will not be calling the main function simply like this. This is an unconditional call. So whenever this script is interpreted, this main function will be executed. I repeat, whenever this script is interpreted, this main function will be executed because it is unconditionally called. What I want to say that I want to call this function conditionally. And what the condition should be that whenever this script is interpreted, then only call the main function. Whenever this script is imported in some other script, in some other program, that time you should not call the main function of this script because this script, this program is imported into another program which will be having its own main function. So that program's main function should be called and not this program's main function should be called. Are you getting it? This is very important. You got two programs, both the programs are modular, both the programs will be having their own main functions. Now, if I'm using this program into this program, because this program making use of some functions which are defined in this program. So when I am using the functions of this program in this program, and when I execute this program, I want that the main function of this program should be executed only and not the main function of this program. But when I import this program into this program, so I will be importing the entire program, though I will be using few functions. So in that case, the main function of this program may be executed. So what we need to do whenever we have a main function in any Python program, in any of our Python program, whenever we have a main function like this, we will not be calling it unconditional. We will be always calling it conditionally. And what that condition should be, it should be a if statement. And what that if statement is, if Dunder name, note it carefully, if Dunder name. Now what is this name? Every script, every program has got its name which is registered into this variable. You can think of this as a system variable for Python. And every program registers its name into this variable, this system variable Dunder name. Okay. Now, if the Dunder name is double equals in single quote. Now, see again carefully. Dunder main. If this is the case, then only call the main function. It means what? Whenever a script, whenever a Python program is executed, the name, the Dunder name of that Python program is main, is Dunder main. I repeat, whenever any script is executed, whenever any Python program is executed, the Dunder name variable is set to a value Dunder main. If a Python program is not executed but imported, if a Python program is not executed but imported, then it will not, then its name variable will not be having this main value. Instead, it will have its package name value or the program name value. So if session6.py is imported in some other program, so its name will not be main, but instead it will be session6.py, for example. But when it is imported in some other, so there it will have a name as session6.py, and for that specific program which is getting executed, for that program it will be having the value as Dunder main. Okay, so this is how we need to do. Now take an example of this. Now this is my session6.py, and this is our code which we have just written. Function sample of funsam.py, and here also we have the fact function. Fine. What I will be doing, let me execute this code. So when I execute this code, see the output carefully. It is 120 and return, not returns, but return a factorial of given number. What I will be doing, let me put this also into a documentation. Now, if I try to execute this, obviously I get an error. Okay, the error is indentation. this. So it says me name fact is not defined. Okay, the exception is what? Name fact is not defined. Why? Because we are calling the fact function. Okay, and here the fact function is not defined because we have documented it, we have commented out. Okay, what I will be doing now, instead of using this fact, I want to make use of this fact, which is available from session 6.5. So since both the programs are in the same folder, in the same directory, I repeat, both the programs are in the same directory, I can write a statement from session, okay, it comes here, session 6, that's all, not pi. So session 6, from session 6, import, and I want to import fact. So from session 6, I am importing fact. So fact function has been imported. And now when I see here carefully, the moment I take my mouse over here, it says me return the factorial of given number. Okay. And likewise here, so return the factorial of given number. If you see carefully, this docstring is a docstring of a fact function which is defined inside this session 6. Returns the factorial of given number, and I can write here this is from session 6.py, or I can simply say session 6. Okay, session 6.py. I come back over here, and then the moment I take my mouse over here, it says me returns the factorial of given number, and this is from session 6.py. And let me execute this code. Oh, I haven't saved it. So here is the factorial of 5, which we have passed, and then the docstring returns the factorial of given number. This is from session 6.py. Okay, and if I want the factorial of say 50, I will save this, I will execute, and this is the factorial of 50, and then it says returns the factorial of given number. This is from session 6.py. Now, a few important things. Here I am writing the name of my program, session 6. Since it is in the same folder, in the same directory, I can simply write it. If it is into the different directory, I need to write the path correctly. Okay. So remember this. And with the help of proper, you can say packaging, we can go for dot also, from this dot, that, and so on, import whatever you want to import. If I want to import everything, I can simply say from session 6 import star. So that will import everything from my session 6.py. But now I'm importing only fact. So I'm saying from session 6 import fact. Okay. So this is how you can define a function in Python. You can do so many stuff. You can import you can import the thing from one program to another program. You can reuse them as per your wish, as per your requirement. And this is how you should have a main function. And now onwards, your all program must be having the main function. Okay, all of your program, Python program, will be having the main function, and will be calling the main function like this only, conditionally. So if my dunder name equals dunder main, then only I will be calling the main function. Else I will not be calling the main function. And here I execute session 6.py. I check for the factorial of 6, and factorial of 6 is 720. Do you want to continue? Yes, I want to continue. Factorial of 7 is 540. I don't want to continue. I come back, and this time I execute funsam, which is using the function of session 6. So this is giving us the factorial of 50 directly, because there we are not asking for the number from the user. There we are not asking for the number. We are simply, what we are doing, we are simply finding the factorial of 50. Here also you can do something like this. What I can do, I can say int, and here itself I can say input, and into this I can say enter a number like this. This looks little jumbled, but I intentionally did it so that we should know that we can make use of cascading. Let's see how does it work. So I go back here and I call the same thing, and it says me enter the number, and I give the number say 3, and it says me this 6, which is a factorial of 3, and return the factorial of given number. This is from session6.py. Okay. Again, I call the same thing and I say I want the factorial of 30 this time. So it says me this is the factorial of 30, and then return the factorial of given number. This is from session6.py. Okay, so this is how you can do cascading also. You can call a function within a function. Very simple to use things in Python. Any doubt into this so far? Please let me know. And here I can change this, as I was saying to you. We can make this as 1, a default one. And if you do not pass any value, so by default it will be 1. Or you can, you can pass multiple values also. What we will be doing with the multiple values? Okay, let's just play with it. For example, I am assuming that is into argument. Number is the first argument, and then after this first argument, the second argument is the message. So in the return statement, what we'll be doing, as I said you that we can return multiple values, or I can simply concatenate the values. So let me see how it would be. A num of 1, and what if I say plus? Let's see. Let's play with this. And here the first argument would be a number, and 1, 2, 3, 1, 2, this one. And my second argument is suppose a message where I need to say factorial is okay. Let's see. We are just playing. We do not know how it will behave, but we are trying it. Let me save this code also. This is funsam, and we will call the same thing funsam. It asks for the number, and we say 6. No, num1 plus f. The concatenation is not allowed. What I need to do then, I can simply pass multiple argument. Oh, sorry, I can return multiple argument. So I can say comma, and it will print factorial is, let's see what it returns. Now this should work. For the number I say 6 and it says factorial is and then comma then 720. So it is working, but can you tell me that how it is packaging multiple values and how it is returning? What type of value is returned over here? Can you tell me? And you should tell me fast. This is quite straightforward and simple. I have already highlighted it. So you can directly come to know. Absolutely right. Yes, tuple. It is a tuple. Okay, so it is creating a tuple out of the multiple values and it is returning you one tuple. So factorial is 720. Now you can do some simple tasks of I can do. Let me concatenate it and let me make it as string. Let's see. So to have it properly, enter number 6. And yes, it works perfectly. So factorial is 720, factorial of 6 is 720. And then a message returns the factorial of given number. This is from session6.py. But this is just for the illustration purpose. It is highly recommended that you should not do this kind of stuff into a code which is going to get reused somewhere else. So you should make it as transparent as possible. You should make it as simple as possible. So this should be avoided, and you should have a very cleanly defined code whenever the code is going to get reused somewhere else. Okay. So your code should do only what is intended to do. It should not do anything which is beyond its scope, and it should not do anything which is below its scope. So whatever is the scope of the function should do that only. That is the main thumb rule whenever you implement a function which is going to be used anywhere else. Okay, so this is something like beyond the scope. We are unnecessarily increasing the scope of a function. The function is just to find the factorial of a given number, and this was just for the explanation purpose that you can pass n number of arguments to a function. Otherwise, this function should be simple enough like this. This become perfect, and here I need not have to pass now multiple values. No need for this also. Yes, I need it. Function. Enter the number 7, and it gives me the factorial of 7. That is 540. And whatever message we want to display, that message we can display over here itself into this print statement. So we need not have to change the fact function of session6.py. Whatever printing you want to do, you can do that printing over here. Factorial of given number, whatever you want to display, that can be done over here. Okay. So this is how you'll be doing a modular programming in Python. Any doubt so far into the
Sir, included